All right, here's my video guide for lesson 6.1.5 titled What is the Relationship? And today we're going to be focusing on converses, all right? Not the shoes. We're going to be talking about converses of statements and converses of theorems and converses of conditional statements here today, okay? The thing that we're really focusing on is going to be this idea of kind of the reverse of congruence theorems, okay? Or really the way that they sum it up here at the bottom is today we're going to be looking more generally at what happens when we reverse a theorem. Okay, so we know conditional statements are those if-then statements, but today we're going to flip those, and what was if blank, then blank, we're going to flip those blanks, and we're going to see what happens, okay? It's easier seen or easier to talk about when we actually get a problem here, but the idea here in the vocab word is going to be the converse of conditional statements all day today, okay? So it says here that Jorge is working with this diagram to the right, and he concludes that AB is parallel to CD, so he writes the following conditional statement. If alternate interior angles are equal, then lines are parallel. So he used the fact that in the diagram, he has these alternate interior angles. It says that they're congruent, so he's saying, okay, then the lines must be parallel. Well, Margaret is working on a different diagram shown below, and she's concluding that X equals Y, okay? And we want to write a conditional statement or an arrow diagram. We're going to be more on the conditional statement side of things today because we're typing it, okay, that justifies her reasoning. And so we're trying to say, if this, then X equals Y. Well, what we can say here is, if the lines are parallel, then X equals Y, we'll say. We could say must equals, but I'm just going to say equals Y because that's what we were trying to justify there, is X equaling Y. All right, and you can see what I did is I flipped this after if and then after then. It became if lines are parallel, then alternate interior angles are equal. But instead of saying alternate interior angles are equal, I'm saying X equals Y because, well, those are the alternate interior angles in this problem. Okay, but this right here, what I just wrote, is the converse to the original statement because it's the reverse of the original statement. Okay, and that's how they're related. Okay, to answer question B, how are they related? Well, the statements have been reversed. Right? What comes after if and what comes after then has totally flipped. Now, both statements are true. Okay, if alternate interior angles are equal, then the lines must be parallel. And if the lines are parallel, then X and Y would equal because they are alternate interior angles. So sometimes we get that relationship where the original statement is true and the converse is true. Okay, let's take a look at slide 3 here. Conditional statements that have this relationship are called converses. I said that, but I highlighted it here as well. Okay, so this idea that you can flip the statement or reverse the statement is called the converse. Okay, so we're going to write the converse to this conditional statement below is if lines are parallel, then corresponding angles are equal. So I'm going to write the converse, all right? And what it is then is if, now I'm going to take what came after then. So I'm going to take this and put it in there after if now. So if corresponding angles are equal, then lines are parallel. Okay? And that's how you write a converse, all right? I'm again just flipping what comes after if and what comes after then. Just flipping those two things. Okay? And again, then you can evaluate what is true. If lines are parallel, then corresponding angles are equal. Well, that's true. Is it true the other way? If corresponding angles are equal, then lines are parallel. Well, it is true that way too. So it's kind of nice. We're going to get some examples later on in this lesson where you could, or we're going to try to think of some examples later on in this lesson of things that are true both ways. True one way, false the other. False one way, true the other. And then false both ways. Kind of interesting, especially because the problem that we're going to be looking at is not going to be related to math. But let's, before we get there, look at this one here. Okay, and this one I'm going to leave a little more blank, not fill in for you because I want to see what you can write here. Okay, and so it says we learned about conditional statements and how they have a converse. Again, it's just flipping. In an arrow diagram, I know we don't use a lot of arrow diagrams, but really in an arrow diagram, it is more visual. You could just flip it so that in this case, it would be corresponding sides are congruent, and then you would put the arrow, and then that means triangles are congruent because really, an arrow diagram is the same thing. This would be if triangles are congruent, and then the arrow is then corresponding sides are congruent. And so we can just flip that as if it was an if-then statement. Okay? So it's first asking, is this arrow diagram true? If triangles are congruent, then corresponding sides are congruent. I think you can answer that one, so I'm going to leave it blank. Okay? It says here, write the converse of this arrow diagram as an arrow diagram or conditional statement. Again, we're using more conditional statements because we're typing them, and then we're going to wonder, is the converse true? So here I want you to write the converse of this statement. Maybe I already said that in this video on accident. Now consider another true congruence conjecture below. Okay? Write its converse and decide if it's true. If it's true, prove it. If it's not always true, then explain why not. So it says, if triangles are congruent, then corresponding angles are congruent. Okay? Triangles are congruent, then corresponding angles. So we want to write the converse of that and say, is it true? If it is, explain the proof behind it. And then if it's not, explain why not. Lastly, we have D here. It says, write the converse of this arrow diagram. Is the converse true? Justify your answer. So the statement is, if a shape is a rectangle, then the area of the shape must be base times height. Write the converse of that, determine if it's true or not. Here is the problem that I was alluding to earlier, and it's this problem where we're going to have to write our own statement that has a true statement and then its converse is going to be true, and we're going to have different examples throughout it. Okay? So it says here, for each problem below, make up a conditional statement or an arrow diagram that meets the conditions. You must use a different example each time, and none of your examples can be about math. So it's really an interesting one to try to think of. Try to keep it unopinionated. Try to use facts when you're making your statements here. So we're trying to think of a true statement whose converse is also true. Okay, so let me think of one that could be. Go with this one. If the Packers score a touchdown, then they get 6 points. So the converse of this statement would be, if the Packers get 6 points, then they scored a touchdown. And both of those are true, okay? Because a touchdown in football is worth 6 points. So if they scored a touchdown, then they got the 6 points. And if they got 6 points, then they must have scored a touchdown. So it goes either way. And that would be your true and true. Okay? Now you're going to write a statement that's true where the converse is false. Okay? And so you got to think of one where if this happens, then it is false. So I don't want to give away too many examples because I want you to think of your own here to write down. But you would have to say, if it is sunny outside, then it is warm. Because then you could say if it was warm outside, then it is sunny. And that could be false because a lot of times it's sunny in winter and it's cold outside. Okay, so you're thinking of statements that have that true and then they're false when you flip them, okay, where the converse is false. So then you're going to have a false statement whose converse is true, and then you're going to have a false statement whose converse is false, okay, and they're all non-related to math. Try to be factual with it and try not to keep opinions in it because opinions could really go either way sometimes. All right, last problem then is this problem number 6, and it's a very interesting problem. So it says, Raj is trying to solve this problem about 3 triangles. He's trying to find the measure of angle H and the length of HI. So he's trying to find this angle measure H and the length of HI. He summarizes the relationship he has found so far in this diagram. Help Raj out. Assuming everything marked in the diagram is true, we got to find these lengths. Make sure you justify all your claims and do not make assumptions based on diagrams. Okay, so I can say that I could start really what I'm going to do is try to make a chain that goes from one triangle to the next and then from this triangle to the last one. Okay, and I can say, well, triangle ABC is congruent to triangle DEF because they have side, side, side congruency. See, 1 tick mark, 1 tick mark, 2 tick marks, 2 tick marks, and a 5 and a 5. Okay, and then you could say if the triangles are congruent, then angle E must be 60 because corresponding angles in congruent triangles are equal. Okay, then you could say, well, then triangle DEF is congruent to triangle GHI because they have side angle side congruency, which means you can then solve for some missing angles and missing sides, and I'll leave it there. Okay, here's a big one for B that I really want you to focus on. I want you to write a careful explanation explaining your reasoning to how you found the values in part A. So if you say H is 16 degrees and you say HI is 10, then I want you to explain here how you got to that conclusion, okay? And be specific like I was trying to be there, saying, all right, I went from this triangle to this triangle using this relationship. This relationship tells me angles are the same and side lengths are the same. Then I went from this triangle to this triangle, and I said that they were congruent and would this is what it means to be congruent. And so just explain your reasoning fully here. Again, we're working into a lesson about proofs, or a chapter about proofs, where we're going to have to be as specific as possible. This is a good place to practice. Lastly, you have your learning log, and it's going to just be like remembering what converses are and explaining what a converse is and how we can use them. Okay, that's it for today's lesson. Reach out to me if you need help on any point throughout it, and you can do that through email, and I will try to get back to you as soon as possible. I like when I get questions.